How you doing, everybody? You're here with Chris at ProCart, and if you've been watching any of the videos or been watching any of the posts or checking them out, you've been seeing that we've been testing our LS3 engine with just a shade under 10,000 miles, and mainly been doing it to check out our MVT370 cylinder head and what it's capable of doing with the right camshaft and different intakes. Okay, and what we were able to find that we can make close to 200 horsepower and 60 foot-pounds of torque difference going from a stock truck engine out of a vehicle with just under 10,000 miles, put headers on it, and put our heads and cam with the right intake, and that's the kind of improvement you can make. You're also going to achieve a lot more acceleration too. You're going to over double your acceleration rate. So that's also really good. And what was really interesting to see throughout this test that, some viewers have commented and whatnot, is that we got to test all these different intakes. And we did all of it for our own knowledge just as much as be able to share some of that with you and what we found. At the end of the day, what you find is that these high ram intakes, definitely for a higher RPM engine like we figured. Okay, so you design an engine for this, you can really make some power at higher RPM, and the engine's going to accelerate at higher RPM greater with an intake. For example, this Holley high ram. It accelerates much greater at that 6,500 to 7,200 RPM range. Likewise, this intake here gives you a little bit better mid-range torque than this intake. Now, they're two different designs. The way they're laid out, from the intake runners to the plenum area, okay, they're different. Likewise, this truck intake restricts airflow and doesn't allow us to go into higher RPMs, which is what this engine wants to do. Meaning, this intake's done at like 6,100 with heads and cam. This LS3, the stock LS3 versus the RCR ported intake. Well, this stock LS3 here makes good power and actually makes a little bit better mid-range torque and accelerates a little better in the mid-range than this ported intake, but at higher RPM, the ported intake wins in acceleration rate. Okay? Likewise, this fast LSXR intake, great intake. We saw drastic improvements when we went to this intake over these intakes right here. Again, you pick up that mid-range torque area. So it all depends on the application, what you're trying to do, and you're looking at acceleration rates. And like I said, what we started with acceleration-wise was 305 RPM per second at peak horsepower average, and 274 in the peak torque area, okay, over the average. Well, like I said, with this guy here, the Holley high ram, for example, we increased that quite a bit to 557 at high RPM and 507 in the mid-range, okay? I call it mid-torque, it's really mid-range. But anyway, this allows the engine to accelerate and breathe. And that's a lot of what this magic is. It's not just about hogging out the ports, let's throw the boost to this thing. This is about, we have an NA engine and I want to pick it up in power. What's the best way to do it? There's a lot of heads and cams for sale out there in the market. We get that, okay? Everybody's buying 5-axis CNCs. We got a 5-axis CNC. But the real magic comes into what you're actually doing with this port and the valve job, period. What we're finding is our intake runner is 274 cc's for this head right here. It flows 376 CFM at 650 thousandths lift. Can't really complain about that, because when you look at a lot of what's on the market with an 823 casting, stock GM valves, if you look at them, those flow numbers are typically in the 700 750 lift area. Okay, I've even seen some as high as 800 lift to get that kind of CFM. We're getting it at 650, so much more streetable head, definitely for the street strip performance. Flows great. Our intake runner stays down so that the volume, so that we can accelerate greater. And we see that just by going from our heads and cam from a truck intake to the LSXR intake. To give you some idea, this LSXR intake with our heads and cam. Acceleration, we get 394 RPM per second at peak horsepower, 420 at peak torque. Our torque ranges, our horsepower and torque, are 579 and 519. That's good pickup for what it is with the heads, cam, and that intake. Likewise, if you look at the difference between this stock LS3 intake and the RCR ported intake, little variance, okay? So not much from a horsepower and torque perspective. In the case of the RCR, you got 566 horsepower, peak average horsepower. On this, we have 567. So it makes just a little bit more. Torque-wise, this guy here makes 512, where this makes 510. Alright? Now, the real magic comes in, the acceleration. We go from at peak horsepower, let's look at that. Our acceleration rate of the RCR is 539 RPM per second. The acceleration rate of the stock intake is 437. So the ported intake wins on the acceleration. So if I'm doing a high performance application, I'm looking at what I'm going to do with this acceleration. And that's what I'm trying to get the harness, and that's what I want to use, because I want to get from point A to point B faster. Acceleration is what wins the races. You can have all the power or horsepower in the world, I don't care. If I accelerate faster, then I'm going to win. And we've proven it many, many times again with engines on the dyno. It's about acceleration rate. And yes, if we can wind the engine higher, make good power and these things, but that engine is accelerating, the air is flowing through it, and now we're filling that chamber with so much more air than what it thinks it can fill, because we got so much airspeed, okay? Those things are really important as we develop our cylinder heads. And we're going to talk more about the cylinder heads when we get with Craig Gallant. We'll do some videos and he can explain some of this. It's really critical that when we start with these engine packages, we actually try to maximize everything we can get out of the cylinder head. And then we do a camshaft for the application and what we're doing, and then we got to pick an intake manifold for that. Because again, it's about the RPM range, which is the operating range that the engine was designed for. And so, honestly, with this setup, this LS3 376 engine, I would use this intake right here for the Corvette it's going into. It's got good torque in that mid-range. I mean, almost 520. It's 519 foot-pounds of torque. It's great. It's a great package. If I was looking for more of a higher RPM where I wanted to stay up all the time, this intake here, the RCR, does a pretty good job from a flow rate standpoint. This LSXR gives us more flexibility, though. It's got a lot more volume inside. It also can play around with runner links, just like this fast LSXHR. This is a great intake too for higher RPM engines. And it also helps keep some of our mid-range torque, which is a really nice thing to have. Now, if I'm going to be racing and go high-end, I can choose and play around with both of these. Now, I will say that this HR, we just didn't have enough area to be able to port with it. We would have liked more porting room, if you will, because we couldn't get the transition totally like we would like it, because we're still in offset, because we just couldn't port because we're starting to get too close to the seal area. Now we could go to a different gasket material and things of that nature and change that up, but just for what we did, the porting where we saw the advantage of this wasn't necessarily power and torque. It was like 1 and 2. 1 horsepower, 2 foot-pounds of torque gain. Where it picked up was in the acceleration rate at the higher RPM. We got to see the engine pick up accel. And what we're doing on a dyno, and everybody always asks, well, how are you doing it? How are you doing acceleration rate, and how are you measuring it? Well, the D-Pack dyno control system has really nice algorithms for it, where it does how it does its calculations under the curve. And when it does and looks at its data, it's giving us an accel rate every 100 RPM. So it graphs it out for us so we can see throughout the pull what the engine is doing at 4,500, 46, 7, 8, 9, 5, 1, 2, 3, and on up. We get all that laid out in front of us so we can see where the engine's starting to lose acceleration, where it's gaining acceleration throughout the pull. It's really great because it knows the control rate that it's set at, and looking at what the change in acceleration is of the engine, it's able to graph that out for us. David Manzolini was a brilliant man when he developed the D-Pack dyno system. That's why it's a great tool. Again, it's a tool. We're not racing dyno cells, okay? We're not racing chassis dynos, we're not racing engine dynos. It doesn't matter about peak horsepower. It matters about the improvements you're making and where you're seeing those improvements based upon what your application is and what you're trying to gain. We can now comfortably tell you, the customer, that you buy our head with this camshaft and the combination of intakes and that type of header, okay, which is a Headman header, and what the primary runner length, inch and 7/8 and whatnot. And we can tell you confidently what the engine power will be. I know I get 180 horsepower improvement and 60 foot-pounds of torque with this fast LS6R intake. That's a given with the heads and cam combo. That's a good increase for just heads and cam and an intake and in headers. That's a great pickup. Now imagine if we put better valves in here and we wanted to boost it. This head already flows good. So now we add a turbocharger or supercharger onto this, and now we can make a ton more power. Make a couple hundred more horsepower if you wanted to. Okay, so it actually was an extremely good test. It was really fun to do for us because we got a lot more testing to do. This isn't by any means done. We have a 414 cubic inch LS3 we're going to build next, because definitely with this head we'll achieve over 600 horsepower. I'd like to see it around 620, 630. Definitely want to see the acceleration rate. We're going to give it a little bit more cubic inch. Let this head breathe. Do a camshaft for that setup. So then you know what you have with 376 inch if you have a 414. And now mind you, you can buy the heads in the cam from us to install yourself. We can install them for you on an existing engine, or you can just buy a complete new engine from us already done. Likewise, we're going to do our 377 cubic inch naturally aspirated drag engine. And that engine will use probably this base of this Holley high ram, and we'll use a different top to do a 4-barrel throttle body. And we might do duals, we'll see. We're going to try a couple different intakes and play around. But our goal with that's around 850 horse or so. With the camshaft we have for that, you know, around 847 thousandths lift. That's going to be utilizing our MVT370 head, which again flows 397 CFM. With a different valve. That's a stock GM valve. If we change valves, we've hit 407. Okay, especially on the exhaust side, we've definitely improved almost 10 CFM on the exhaust port just with changing to a Ferrea valve. And so consequently, we're going to do that in that first engine that we do, and that's going to be in the 2010 Camaro of Nicole's that she'll race and get her going in that. And then we'll do a 1,000 horsepower package, which will be over 1,000 horsepower NA package with a whole different setup, with different heads and whatnot. But first we want to showcase the 390 head, because we're getting good results at higher RPM, 750, 800 lift, and 850 lift with this stock GM cylinder head, okay, that we're able to achieve just a little over 400 CFM with the stock head. So that's actually really cool. Think about what we can do with that. In stock valves, we hit, like I said, 397 CFM. That's pretty good. So let's go for that, and let's give it what it wants, and go race it, and then we can see what we can do with that engine. Likewise, we're going to build an LS7 engine and test and show you the improvements on those cylinder heads. I mean, we did an LSX 454. We made over 600 RPM range. We made an average of 714 horsepower. Over a 1600 RPM torque band curve, we made 627 foot-pounds of torque across it. Okay, we had a peak of 634 in one spot. So just from a stock LSX 454 with our LSX LS7 head and camshaft, that's the improvement we got just by slapping that on. And then we're going to slap on another 200 shot of nitrous on top of it. So the improvements are there, and we're proving out what our solutions can do, because, hey, we want to know as much as you do what they do, and we want you to know what you're getting when you buy this stuff. So I hope this was very helpful for you. In summary, you know that you can get quite a bit of improvement with the MVT370 head. We know we can over double our acceleration rate. Okay, we can just about double it. All right, just going by heads, cam, the right header with the right intake, and picking the right intake for your application. Okay, do you want more of that? Wind it to 6,500, have your torque be a little bit lower in the RPM band, or do you want to move it up higher in the RPM? It just depends on the application, but we can talk to you about what those solutions are, and you know what you're getting when you buy our cylinder head, because we've tested it. And we're going to continue to test it throughout this process, and we're going to share more information with you. So if you got any questions, please feel free to give us a call, or you can message us on Facebook. I appreciate you watching these videos. I hope they're helpful for you. I hope you can get something out of it by seeing the different intakes. This truck intake restricts you a little bit more, isn't the greatest acceleration. RCR ported definitely gives you higher acceleration up top. LSXR gives you good mid-range torque and acceleration. The stock intake still gives you good performance. This LS3 intake's a great intake. These two intakes, definitely higher RPM, power band, but gonna let the engine breathe up high, so you get really good response. The fast LSX HR intake gives you better rate, better torque down in that mid-range versus this Holley high ram. Different types of intakes, different applications you can put it towards. So again, it goes back to what you want to do. The biggest thing is you can know you can get the solution here from us, and I hope you feel confident about that. And like I said, I hope to share more technical information with you. We're going to do some stuff about cylinder heads, valve train. We're going to share all the information on the other engines we test as we go. So stay tuned. Definitely more to come. Thank you for your time and watching. Have a great day.